Going twice, going good. So that means everyone is already situated in a group. So that's good. Do you guys have any questions about the project?
So we're gonna like figure out all the stuff and how to set it up and simulate it, right?
Okay. It's always good to start early. But if you ever come up, encounter an issue or something, please let me know. Not technical issue, like, AutoNet models. That's part of your exercise. But if you need guidance in general, just let me know. Like what kind of results you're looking for. Things of that sort. I can help you with. Okay. Before we proceed, any questions, comments, requests in general? Okay. So today we're going to design a full service. Okay, a very high level. Just pay attention because traditionally I've been getting this as a problem on the phone. Okay? So please pay attention and stop me wherever you think I need to re-explain or elaborate further. Don't be shy, okay? We'll see how far we'll finish today. Either we finish it today or we can continue next time. It doesn't really matter. But what matters to me that you understand this 100%. Because you guys can see my screen, right?
Yeah.
Okay. So this is a service. Can anyone give me an example of a service?
Can you clarify? Are you saying server or service?
Service.
Like Netflix?
What kind of service? I'm sorry?
Media?
Media is not a service. Media is not a service. What you do with the media is a service. Like social media. That's a service. A website or an app that makes you play online. An app or a website that allows you to communicate via email. VoIP. Like these messengers and stuff that you download. These are services. Banking, right? That's a service, online service, correct? Any other examples?
Online streaming?
Restoration. Awesome. Online or media streaming, like Hulu, Netflix, Amazon Prime, Apple TV. Yes, these are services. Other examples, please?
It would be like shopping service, as you said.
Shopping, awesome. I love that, yes. Shopping, online store. Yes, exactly.
Cloud storage.
Come on, guys, you're smarter than that. Go ahead. What?
Cloud storage.
I'm sorry?
Cloud storage.
No, cloud storage is a system. Okay. It could be a service, but from where I'm coming from today, it's just a partial service. Because all these elements that you see, like email, social media, you're gonna have to have some storage that can be put in the cloud. I mean, that's a good way you're thinking about it from your end. So I applaud you. But more of something that definitely, yeah, cloud storage. You know what? You're absolutely right. You're absolutely right. Cloud storage. You're absolutely right. Let me just write it here. Cloud storage. Thank you. Other services, guys, come on.
What web hosting?
I'm sorry?
Like website hosting?
Okay, I'll put it website hosting. Okay, I'm gonna put those two in a category by themselves. Okay, because these are more for programmers or certain type of profession, as opposed to these ones that 100%, almost 100% of the population can interact with. Don't you agree?
Yes.
Yes.
Like who's gonna do cloud storage directly? Of course, we do it like we don't know. Like you save an email or a picture, your social media goes to your cloud storage. It is a service, I totally agree, but it's not applicable to everyone. You know.
Professor,
So, go ahead.
can we like maybe consider like Uber and Lyft like transportation as a service? Like
Say that again. I'm sorry.
Uber, like transportation, it's a service.
Awesome. Yes, actually, that goes right here. Yes. Uber. Yes. Awesome. So yeah. So all these are services, but the cloud storage, website hosting, these are for the elite. Cloud computing, that's not really my topic today. But all these email, Uber, social media, gaming, VoIP, banking, school registration or school transcripts website, media streaming, shopping. That's what I mean today. Okay. So most likely, the majority of you, if you're successful in getting like really decent GPA, and you're lucky enough in your interview, you'll be working in one of these big companies that most likely will be designing one of these things. Like social media company, an email, like a Google Gmail, you have, you're gonna do like online shopping, like company like Amazon. So if you're lucky enough to work for one of these companies, you will be encountering today's lecture. Also, all of us use these services, right? If someone of you guys does not use these services on daily basis, me right now. Okay, so all of us are using it. It's good to know what's happening in the background. When you send someone an email, what's going on? When you talk to your friend in France with this super nifty VoIP app that you just downloaded for free, what happens in the background? How the system behind it? So you cannot take a telecommunication course like 460 without understanding what's going on, how things are being built and communicate with each other, right? You guys agree, or do you have any comments? Or I like to hear you guys. That's why I keep asking you questions, just to hear you interacting with me.
Yes, we agree.
I agree. Yeah.
Thank you. So you have to attack any topic bottom up and top down. So bottom up, like you go through the details, like 7 layers. That's what I've been doing so far. Today we're gonna do top down. Top down, like look at the huge, big picture from 5,000 foot level. Then you dive deep. So you have to attack the problem from up and down in order to understand it. So today's lecture, we are going to design a service and let it be VoIP service, voice and video over IP. Yeah, I'm gonna clear this. So you met your friend today, and she told you, "Hey, there's this great app, VoIP app, online, and it's only 99 cents a year, but it's a great app. You can talk to anyone. You know, it's very nice." What's the first step you're going to do?
Ask what the app does.
No, she told you already the app does voice over IP, voice and video over IP.
Ask her the name.
So you know, no, of course she gave you the name. So what's the first you do?
Search on them.
Download the app.
I'm sorry?
Download the app.
Okay. Yeah, so yes, exactly. Exactly. You do what? You download the app. So of course you're gonna go to the app store. By the way, these are devices. So this is a cell phone, this is a tablet, this is a desktop. So these are the users. Okay, these are the users or consumers like you and me. The first thing you're gonna do, you're gonna download the app store. Tablet or your laptop. So in any network, you have two zones. You have untrusted zone. But please take notes and take screenshots because this is very important, okay? And you have trusted zone. The untrusted zone, that's the internet. You know, no one really trusts anything happens on the internet. So that's untrusted zone. The trusted zone, that's the company that hosts your application server. It's called the core. That could be a cloud service provider like Google or Amazon or Azure. It could be a telecommunication company like AT&T or Verizon. But this is just like a huge, huge company with like probably international reach. So they have data centers. And for those of you who never seen a data center, it's big buildings and full of racks. And each rack has like a lot of servers. And some of these servers that will host your credit card information, for instance, or your social security or driver's license, will be placed in a physical cage, like stainless steel cage, you know. So these are buildings, or sometimes like big, very big complex units, and they have central air conditioning. Sometimes the air gets purified, so the humidity and other dust and particles do not ruin the servers. And if you're the designer of this project, you will talk to the engineering group that controls these physical servers, and it's like, you know what? I'm building a VoIP service. Give me give me 10 servers on this rack, and a couple of them will be highly secure because people will pay 99 cents so they can put their credit cards, date of birth, or whatever. So put them in a cage for me. So I kept saying cage a couple of times because in this era, every time you mention cybersecurity or security, use like, oh, viruses, antiviruses, malicious applications, jamming signal, all these electronics. But only few think about physical security. You know, your server could be the most secure server in terms of firewalls and etc. But the building does not have good security. And by the way, good security starts with like physical like guards and CCTV, like cameras and stuff, and sensors. So the group can just go to the building and steal the whole server, or can stick a USB in drain all the information out of it. So you as young engineers, I want you to always think of security, but not only the digital security. You have to look at the big picture. The big picture that physical security plays part of. So the core, these are the buildings, the data centers of this company. Be in a cloud, because what's the cloud at the end of the day? Did you hear this joke? The cloud is only someone else's computer.
No.
From a physical sense, it's a widespread joke. It's like, so even the cloud is like a big building or buildings have blank servers waiting for your virtual machine to reside on. So the premise here is called, the premises here are called trusted zone. Okay, so you have to distinguish between trusted zone and untrusted zone. So, by the way, we're designing VoIP app, but it's the same design for email, for school transcript, like the whole list that we started off the class with. It's applicable. It's the same design, guys. So, what is the brain of any service?
Server?
Of course, a server, but what it's called?
CPU.
I'm sorry?
The CPU.
No, CPU, that's the microprocessor. It doesn't have anything to do with it.
Flash drive or solid state drive?
No.
Main
Application
server?
Application server. App server. You guys never heard about application server?
No.
Okay. So now it's something new to learn. So any brain, so the brain of any service, either email, school transcript, VoIP, gaming, anything you just think of. The brain for it is called application server. And I'll talk for a few minutes about what does the application server do, but later on. So now we'll start to get the components of a service together. So you need something called front-end developers, because I'm sure like many of you start looking for jobs, and you don't know which one does what. So the front-end developers, these are the front-end, so these are the people that design the application. So you're going to have an Android application, iOS application. So these are called the front end. The back end developers, these are the people that do the app server, the brain. Any questions? So look, guys, I'll be very frank with you, okay? This whole thing will be coming on the final. Okay? If you don't do 100% right, I'm not going to give you the grade because I'm telling you it's coming. So if you ignore it and you don't get it, that means you don't really care about the course. You don't care about the grade. I'll give you what you wish for. So please, 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 if you have a question, ask it now.
So the
Like, just 1 second, please. And over the semesters, I give them this question. Trust me, those students who screw up, I make sure they never pass, never get an A. So they will be starting from B going down because I already told them it's coming on the final. So don't sit right there and just like, oh, I'll be understanding this later. Okay, questions?
yeah,
If you don't have questions, fine. Just 1 second, I'm sorry for interrupting you again. If you don't have questions, fine, but I just want to make sure that everyone is paying attention. Go ahead.
so the back end, they don't really deal with the layout of the application. They just deal with the logistics.
So, what do you mean logistics?
Like they don't worry about how it looks to the user. They're worried more about implementing the concept.
Yes and no. You're absolutely right. But if you can help the front end guys to make the app looks nice and user friendly, do it. So what you were just describing, that used to happen. The front end and the back end folks do not talk to each other and disasters happen. Okay? New motto in the industry is like win as one, meaning what? Like all the teams work together. So that's something, that's another piece of being team player. You know, so you should be caring about the front end as well, if you're a back end. So some of you may think it's like, oh, we're not software engineers. Why the professor is giving us this? First, I'm giving you the networking aspect of it. But in today's job market and today's technology, you have to have some software understanding. I'm not telling you to go program like for NASA, but at least understand what's going on. Okay? Because I'm not going to dive that much deeper today or like in this class. But you as a network engineer or communication engineer, you really care about the front end guy that put delay tolerance for 2 milliseconds. So when you design your network, you should not exceed the 2 milliseconds. So you see, like if you're superficial, it's like, oh, we're not really software engineers. Why do I care about back end and front end? Because if you work in this industry, you're going to be interacting with them. You have to interface with them. You know, no one works in isolation. So, a question to you guys. For any ABC networking engineering, what kind of device you put between trusted and untrusted zone?
Firewall.
Thank you. Firewall. See, that's like ABC telecommunication. You put a firewall. That's even before you start talking. So these are 3 firewalls. I'll tell you why there are 3 firewalls. So let's go back to the sequence. You downloaded the application. What's the next step to do that you should follow? You should do.
Open it.
Yeah, of course. But
Install.
what's the next 3 or 4? Sorry?
Install
Yeah, after installing it.
it. And then you set it up.
Setting it up.
What do you mean setting it up? Like, give me more details, please.
Register yourself.
Register. Thank you. That's the word. Register. So in our world, as telecommunication engineers, register, that's called provisioning. So provisioning. I don't like people joining late. Provisioning. Okay. And this is provisioning firewall. Provisioning firewall. So in the registration of the provisioning, what do you do? I need more explanation, please.
Identify yourself as a user.
So you go ahead, you put your first name, your last name, you choose a username, you choose a password, you associate an email. Sometimes you have to put your driver's license number. Like sometimes if it's a banking system, some application now they ask you to take an actual picture of you, a photo of you. If it's a paid service, you have to put your credit card information and your physical address. What else? What else in the registration, guys? Come on, think. When you register for a decent app that you pay money for, what other information you put?
Credit card.
Yeah, I said credit card. What else?
You
Sorry?
put like phone and address.
You put your address, your social security,
Sometimes it can ask
and you choose.
device permissions.
Sorry.
Sometimes it may ask for device permissions, like do you have permission to access the photos or your
Yeah,
camera?
that's local. That's local. That's local. Yes, I agree with you, but that's local. Now, if you look here, I'm talking about what information you need to register with the application server.
Okay.
But yes, you have to get the permission, but that's part of the installation.
Do you set up security questions?
Yeah, security questions, good. And also, you have to select what kind of service you're asking. Because many services, like, oh, you want the basic, you want the premium, you want the super premium, you want the business grade. So you choose a class of service as well, right? And of course, the higher the service, the more expensive it is. So you send all this information to the firewall, provisioning firewall, which sends it to the application server. Then the application server saves this where? Guys, if you're making noise, just please. So, where you put all this information? You guys can hear me or not?
Yes, Professor. I think that's your computer.
Yeah.
Yeah, I think it's
computer.
on your side.
You still can see my screen or not?
Yes, Professor.
Yes.
Okay. So all this information associated with Smith, where does it go?
The rack.
Database.
No, a database. A database. So now the application server will create an entry for you with all the information you put. You know, all the information. The application server, in a perfect world, in perfect design, does not store data. The database does. So if you're a network or telecommunication engineer, and you hear someone is like, oh, let's store this data on an application server, you don't say no, but you say why. You say this the job of the database. You know? So it goes to the database. So what else I want to tell you guys here? So what does this firewall do? No, before that, when you download the application, how the application knows that to provision the service or register, it goes to that firewall, not this one, not some other firewall, in some other country. How can the app on your phone knows to be pointed at that exact firewall? Can anyone take a guess?
I think
I'm sorry?
The cookies would identify it as a first-time connection.
There are no cookies yet. There are no cookies yet. You know.
I would guess maybe like when you press register. Right?
Would it be
So basically, when you download the app, I'll tell you. But thank you so much, guys, for answering. For trying to answer. I like that. When you download the app is just a package. Someone of you said install. When you install, what you do, you unpack this software package and affix it to your operating system somehow. Part of the process, when you unpack the app that you just downloaded from the App Store, it has the IP address or the DNS entry or whatever. Just make it simple for you. So it has the address for that firewall. Okay? So that's what you do. So now you're registered and all your information is in the database. From this architecture, what is the most sensitive element from a cybersecurity perspective that I have to protect with all my resources?
The database.
Thank you. The database. And let me tell you this. If I infect this, your phone, I'm going to take only your phone's information, your personal information. If I infect 10 phones, I'm going to take 10 persons' information. But if you only hack this poor little guy, the database, you can literally take millions of customers' information. Most likely, if you read in the news that some big shot company or a credit bureau or whatever lost 80 or 100 million customers' social security or names or driver's license or whatever, 99% the hackers got their hands on this piece, the database. Okay. Not because the hackers are smart. No. That because the engineers that were supposed to be protecting the database did not really do their job. Because the database everything has to be encrypted, secured. In real life, guys, even around the database, there are like little firewalls. I don't want to show it here. So forget about this huge firewall, but even within the trusted zone, everything around the database is like firewall. So the database should be an island. But the problem, many engineers or many companies do not follow the best practices for cybersecurity. That's why you hear about all these breaches. I'm not saying if companies will follow the cybersecurity policies and rules and standards, they will be safe 100%. But it will be extremely difficult to hack. As opposed to now, every few weeks, we hear like, oh, this email server or service got hacked and people's emails are being sold on the black market or something, or the underground market. So far, everything's clear?
Yes.
Good. So now you install the app. The app is working. You put your credit card information, and you got a green light from the application server. Of course, you don't know the application server, but you get a message like, "Oh, now you're good to go use your app." What's the next thing you want to do? You want to call your friend, right?
Yeah.
So remember when we talked about calling, you don't call right away. Remember when we talked about packet switching and circuit switching?
Mm-hmm. Yes.
We said that there's a negotiation, like a phase where negotiation happens. It's called call setup or signaling. And I'll tell you exactly what happens in the signaling. So, by the way, this is the signaling firewall. Okay? Signaling firewall. So now we want to call your friend. So Smith wants to call Anne. So this is signaling. So the signaling, Smith wants to talk to Anne. So when you go to the signaling, the call goes from your app on your computer or your phone or your tablet to the signaling firewall. It goes to the application server. The application server checks the rules. It's just rule validator. Rule validator. Meaning what? So Smith wants to call Anne. So you're gonna first signal. And the signal, when you call someone, guys, via VoIP app, it's literally the half a second or a fraction of a second before the phone starts to ring. The phone actually tries to do signaling. But because the technology is so amazing, you don't really feel it. It takes like literally 0.2 or half a second. Once signaling is done, you get the ring. That means the other person is ready to pick up the phone. So in the signaling, Smith wants to call Ann, or Bob wants to call Ann. So Bob, the application server first will check Bob. Is Bob a paying customer? Yes. Does Bob have the latest software, latest version of the application? Yes. Does Bob have an approved phone? You know, sometimes you try to download an app on a very old phone, it may get installed, but when you try to reach the service, it tells you your browser is out of date, or your operating system is out of date, or your phone is out of date, something like that. So the app checks. Okay. The app also checks the class of service. Are you a paying, what kind of paying customer are you? Did you include call overseas, for instance? Did you include the service to call overseas? The app server will check that rule. Yes, Bob is allowed to call overseas. Did Bob dial the number correctly? Yes. In case Bob did not really dial the number correctly, there's something here attached to the app server called Media Player. Media Player. How many times you try to call someone and after a couple seconds, you get a message played back to you? The number cannot be whatever as dialed.
Lots of
Are
time.
you guys familiar with it?
Yeah. Like the phone is closed or unavailable or something like that.
I'm sorry?
Like the phone is closed or unavailable or something like that. Yeah.
Yes. Or you're not allowed to do that. So many situations you have this media player plays a message back to you. That means you flunked one of the application server rules and you're getting back that. Or maybe Ann is not available for whatever reason, so you're going to get a message back as the part you're trying to reach is out of service or out of reach or whatever. So these are the things that you guys deal with on daily basis, right? But you, as telecommunication or networking engineers, you don't really know much about it. So I'm trying to demystify the whole aspect behind it.
Professor?
Yeah.
Question. So some of these rules have priority, right? Because if the phone is off, that will be checked first, I believe, or something like that. So it's off, not even to bother, if it's a paying customer or not, something like that, right?
I'm sorry, say that again.
I just said some of these rules have priorities. If the phone is off, that will be checked first, I believe. If it's off, there's no point in checking if it's a paying customers or what kind of plan they have, something.
Yeah. So it's part of the rules. I didn't really get the rule you're mentioning, but it's all kind of rules that if you don't satisfy any of them, you get an error back or a recorded message. So now this is called the first leg of the call. So see, this is the first leg. So the app server is happy with Bob. Now the app server will go to the next leg, which is from the app server to Ann. The same thing he checked for Bob probably will check it for Ann. Is Ann in good standing in terms of paying her bills? Does Ann have the latest phone and software version that I can support? Does Ann reside in an area I can serve? If you're talking about international services, there's some areas or countries or regions the U.S. is not allowed to do business with. Okay? So The app server will check all these little things. Once the app server is happy that Bob and Ann can actually make a call, it comes the third leg here that's called media. Media and this is media firewall. Okay, media firewall. So basically, media is that actually when you start talking and sending videos or sending pictures, that's you're exchanging media. And that's a very high level. Any questions so far?
Can you explain what you mean by high level?
No, because if you design something like this in actual world, it will take you like at least 8 months to a year and a half. So that's what I meant by high level.
Oh, okay.
Yeah, believe it or not, about 100 people have to work on this, from 50 to 100 engineers, like very skillful engineers, and it will take average from 8 months to a year and a half to get something like this up and running. So, remember when I talked to you about Kalia? If someone is committing a crime and the government will have a valid court order and will ask the service provider to give him a backdoor. You guys remember that? I told you Kalia, C-A-L-E-A, to go look it up. Yes, no?
No.
Guys, if you don't remember,
No, I don't.
maybe you're, okay. So, if someone is being suspected or whatever, the government thinks that he or she's doing something wrong, they can get a valid court order for the service provider. That's called service provider. Like whoever owns that system called service provider. And the service provider by law, if the government agency has a valid court order, there's something called Kalia. You guys can look it up. It's right here. That's okay. Kalia. So basically what happens, the service provider will give a little backdoor here. Little backdoor. So a government agent with a valid court order can listen to conversation. That also goes into application server. So they can do a lawful, it's called lawful intercept. Okay. So let me ask you a couple questions. Remember last time we talked about capacity engineering?
Yeah.
Yes. So now you're the telecommunication engineer that designs the firewall. Which firewall should be the smallest? Which one would be the biggest?
The biggest is last one.
I'm sorry?
The biggest is probably last one.
And what's the smallest?
Signaling, probably.
No, but you're half correct. So let me tell you this, guy. In terms of usage, when you download an app, how many times are you going to register in your lifetime?
Once.
Once. So let's say, yes, once, but every 6 months, you're going to go change, like you moved, you change your physical address, you want to put another credit card, you want to change your zip code, your new phone number, and your email. So I would say twice a year, right?
Very good, yeah.
Make sense? Okay. But you call your friend or your friends and family members 10 times a day. Which firewalls are they going to hit 10 times a day?
Media.
Signaling.
Signaling and media, both, right? Because you
Signaling.
cannot go to the media before you're doing signaling. It happens prior to every single call, right?
Yeah, yeah.
But
Well, yeah.
okay. So do we agree the smallest one or the least used one is the signal, the provisioning?
Yeah.
Okay. Compare between signaling and media. Which one has standard low usage, signaling or media?
Signaling, I guess. Signaling.
Let me tell you this. Can I tell you to talk to your friend only for 2 minutes and hang up?
No.
Can I tell you do not send a lot of pictures to your friends or videos?
No.
So the media is unexpected. It depends on the user. You know, they may want to talk for a minute, but they might want to talk for an hour. They may want to send a picture, they might want to send 2,000 pictures. So the media, it should be the biggest. For the signaling, it's machine to machine. So always when you have machine to machine, because now the app on your phone communicates with the application server, they're very efficient. When you have machine to machine communication, things are very efficient. It's normally using a language called SIP, SIP, Signal Initiation Protocol. So in SIP, it's very compacted messages. It's like, what's your phone version? What's blah, blah, blah. It's like a string or a couple of strings of information. You send them automatically before the call. So there's no like back and forth, like a lot of back and forth. So even the signaling is very predictable. It's like 99% predicted, the size of the packet. So I don't care who's calling whom, the signaling most likely will be the same size. So you can accurately, if you know the number of users on your service, you can accurately predict the number of packets. But is there a way to predict the number of the media the media firewall, henceforth the CPU and the memory that you use? Very difficult, right?
Yes.
But I'll go back to the previous lecture. That's why you have research teams or research or firms that will do that job for you. It's like, you know what? If you are going to deploy your service in this high school town, oh yeah, these are high school kids. They always love to send text messages during school hours and after school hours, like video and pictures. So now you can size up your traffic. It's like, oh, and probably going to get 1,000 customers increase every month because these are teenagers and they imitate each other, so you're going to grow rapidly in this market. Guys, remember last lecture when I told you about how research firms gather intel or information on how the growth will happen? So capacity planning engineers can account for that. I'm just trying to put things together now. So I give you last lecture as a standalone, and this lecture, so they're both together actually. And actually, that will tie to the redundancy as well. Because see, the system, if you're going to have the system in the East Coast, you're going to have something else on the West Coast, geo-redundancy. And each firewall, that's not a single firewall. You guys remember the redundancy? We're putting it all together here. That's why I love to get this at the final, because it's just one problem, and I can gather a lot of, I can pack it with questions just to see if you understood a lot of topics or not. So the firewalls here are in pairs. Remember when we talked about local redundancy? They work in pairs. Okay. We're almost done, by the way. So just bear with me a few more minutes. Let me ask you something. How many of you did the following? Your friend sent you a nice picture and added that chat, like the VoIP chat, you uploaded it to your social media network directly. Who's familiar, who's not familiar with that?
I'm not familiar, sorry.
You're not familiar with that?
You mean uploading a picture of the chat or like the chat itself?
Like, yeah, no, like I can send you a picture if we're chatting like via Viber or something or WhatsApp, and you can do share directly from the chat, your Facebook or Twitter or something like that.
Oh yeah. No.
Exactly. So how this happens? It's part of the service now, guys. Because now everything you do, any media you get, you click share, and it gives you all the options for other services. That's the secret. Try to make the system interoperable to encourage like more people to join. So I'll go down here. So we have something called converters or translators. So this converter, that's SNG. So it comes here for instance. So this is SNG. Social Media Network Gateway. So that box will convert the language that you're talking here, the protocol, either you're talking SIP or RTP, real-time protocol, whatever, to the social media language, social media protocol. So it's just a converter or an adapter or a gateway. You see? So that's just a gateway that converts the local language, local protocol, parameters, variables, into the social media variables. So that's how you're able to upload a picture directly from your chat to a different platform. Let me ask you another thing. Can one of your free app call, of course you can call someone who has the same app, but can you call someone who has a 4G or 5G cell phone?
Yeah.
Not really. You have to be a paying customer. All the free apps do not do that for you, as far as I know. But some apps, fancy apps, if you pay, they will connect you to some like 646 or 917 or something like that. Or even a landline. How? You have also adapters for that. So you have an adapter for someone who is 5G. What's that? You know, or landline, PSTN. So you can call from an app, VoIP app, to a PSTN, a landline, or a 5G. How? Via adapters. So via adapters, you can do that. That's what I really have. I mean, I could be talking about this for like the next 200 hours, literally, and not finish. But that's a very high level, and I guess it's just good enough for your level, guys, without boring you with the tiny details.
Professor, that's a quick question. Like, what kind of like stuff that needs adapters? Because like I remember like.
I'm sorry. What kind of what?
What kind of like stuff you need adapters for? Because I remember you like you mentioned like, for example, when two devices like maybe like one new and one old communicate during the session setup, sometimes one can transfer data like with a less rate to match the other, but when you say like 5G is like a totally different like play field, so it has to use an adapter, right? Something like that, right?
Adapter is like a translator. Like what's really an adapter is a software code that translates one protocol to another protocol. So for instance, if you're using SIP for signaling and RTP in your service here, and 5G uses certain types of packets. So the 5G gateway or the translator or converter or the gateway here, it just translates the SIP protocol to a signaling that the 5G network understands. That's what it is. You know, it's not some. Of course, it takes like literally thousands of hours to develop that gateway or translator, but for your level, it's just a simple translator. You know.
Okay.
And of course, the people who write the adapters, they have to be very familiar with the two languages. Like the service here, what does it, like what language it talks, like if it includes a picture for instance. Does it use JPEG, JPEG or JPG or like all these formats or MP, whatever. And if you're going to send a picture to someone in 5G, what does the 5G use for pictures? So you convert JPEG to whatever, PDF or something like that. You see? So you're just changing the formats of the network. You know, that's why most likely these services are for free. It's very easy to talk to someone, like you download the Viber app, Viber to Viber, that's free. But if you want to talk to someone with like an actual phone without the app, you have to pay them. I'm not sure, but I think that's what it is. So that's basically, I don't want to go further here. Okay. I mean, I don't want to give more information because I believe this is like the exact right amount for you guys. Any thoughts? Any ideas?
Professor?
Anything you've been practicing every day when you use these apps and you're wondering how it's working? Yes.
Quick question. Could you please explain a little bit more what's the exactly firewall? Because I have kind of broad idea of what it is.
Which one?
Firewall. What's the firewall exactly?
That's a good question. That's a very good question. So firewall, so here's the thing. You downloaded the app. Firewall is just a security gateway. So I know Joseph downloaded that. So when I tried to register the first time, the firewall will look. Did Joseph try to register before with different name? Yeah. So probably he's playing game. I'll block him.
When we were on our fresh control.
My room?
Or
No.
when.
Oh, Mama.
Or signaling.
Look.
Supposedly, how many times you do signaling before the call?
This is something
Just once, right?
Yes.
But if I try to do signaling and hang up, signaling and hang up, signaling and hang up,
but my name's gonna be
that means I'm trying to mount DOS attack, denial of service attack on that firewall.
Wow.
So that's not like a genuine person wants to make a call. Someone is trying to play with the system, trying to send a lot of signaling to this firewall, and if this firewall contains only 10 streams per second, and you pick 10 streams, that means you deny the service to all other legitimate users. Okay. Also, the firewall, if I say this is a local service to people in New York, I'm not going to be able to support people like overseas, like only the US. And you try to register for that service from Canada. The firewall will detect your IP as like, you know what, this guy is not really, should not be allowed to register. You know, that's why so many apps, they have different versions. Version for the US, version for Europe, version for the UK, and version for Canada or Australia. Why? Because these firewalls, they will direct you to different firewalls. You know, try to register in the US with an app you downloaded in Europe. It will not work. It's the same company, same app, but different version. So the firewall just makes sure that you're not trying to trick the system. Okay. It's one more advanced technique. You could just download a hacking program, and you can simulate phones. You know, and you try to send like malicious software to the application server in the database and try to steal the information in the database. It's very sophisticated. So you send that. Okay, it's too complex, but take it like as it is. You try to send like a seemingly benign signaling message, but in actuality, you want your traffic to reach the database to implant a virus there that can later on send you the information. So these are the few examples of what the firewall does. Does it make sense to you?
Oh yeah, thank you very much. Thank
You're
you.
welcome. Okay. Any other questions, guys? I hope you take a screenshot of this. And please pay attention. On the final, I'll get this. It will be combined with capacity planning question and redundancy. Okay?
Yes.
Okay, so if any of you doesn't get it like 100% correct, don't blame me. Yeah, please. It's right there. I'm open to discuss it again next time. Not the whole class, of course, but if you have whatever questions, I'll be more than happy to answer you.
Just one more question. Sorry.
Sure, go ahead.
Whatever we're gonna implement, if it's gonna be social media or gaming online, all of them gonna follow these steps. I said like
everything is the same. Everything's the same. Everything like gaming. Everything will be the same. Like gaming, you have to signal first, and the media will be when you move the arm or whatever, that you send media, like video back and forth. It's same exact concept. What changes is like the app and the application service. But everything is pretty much the same. From your perspective as a network engineer, everything's the same pretty much.
Got it. Thank you.
You're welcome. Questions? Okay. Have a wonderful evening, everyone. Please mince it. Try to see if you have more questions or something, and I'll be happy to answer them next time. Okay? Or you can send me an email. I can meet you early on Zoom or whatever. But please, 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 these are one of the few things I want you to get out of my class understanding, because this architecture, you deal with it like every single day so many times. So it's very good for you to know. Okay? Good night, guys. Bye-bye.
Thank you.
Thank you.
Thank you, Professor.
Thank you.